Today, I want to talk about one of the most important, but also misunderstood concepts in electronics reliability, and that's latent failures. These are failures that don't show up during manufacturing, they don't show up during inspection, and they don't even show up during electrical tests, but they will show up in your customer's hands, in the field, and at the worst possible time. Stick around to learn more. Now, before we go any further, let's ground this discussion. Electrical tests, functional tests, and ICT tests are all valuable tools. They're essential for verifying that the circuit is assembled correctly, the components are functioning, and that there are no immediate defects. In other words, they answer the question, does it work right now? But reliability engineers need to answer a different question. Will it still work later? And that's where latent failures come in. A latent failure is not an obvious defect. It's a hidden condition that develops over time. The product leaves your factory looking perfect, behaving perfectly. But under real-world conditions like temperature cycling, humidity exposure, and electrical bias, something begins to evolve. Not instantly and not dramatically, but gradually. In electronics assembly, one of the most common drivers of latent failure, among others, is electrochemical activity. Let's walk through the mechanism. First, you have residues on the surface of the assembly. These can come from flux, cleaning processes, handling, or the materials themselves. Those residues often contain ionic species. Now, introduce moisture, which is almost always present in the real environment, and finally apply a voltage bias. This combination of residues, moisture, and bias creates a system that is no longer stable, and at that point, several failure mechanisms can begin. Electrochemical migration, which leads to dendritic growth between conductors, leakage currents, and corrosion. And here's the critical part. These mechanisms don't trigger an immediate failure. They initiate, grow, and eventually cross a threshold. So at ICT, everything looks fine. During functional tests, still fine. Even in early life, still fine. But over time, a conductive pathway forms where none should exist, and then the failure appears. So the failure wasn't random, and it wasn't sudden. It was already in progress the entire time. And this is where traditional testing falls short. ICT and electrical tests are snapshot measurements. They capture performance at a single point in time, but latent failures are about time-dependent behavior. This is exactly why surface insulation resistance is so important. SIR is not trying to answer, does it work right now? It's designed to answer, how does the system behave under stress over time? SIR testing intentionally creates the conditions that drive latent failures. Elevated temperatures, high humidity, and continuous electrical bias. These are the exact same factors that exist in the field, just accelerated. So while electrical tests tell you the product works today, SIR tells you whether it will continue to work tomorrow. If your goal is simply to verify the assembly, electrical testing is sufficient. But if your goal is ensuring long-term performance, preventing field failures, and generating objective evidence of reliability, then you need testing that reflects degradation mechanisms. And in contamination-driven systems, SIR is one of the most powerful tools we have to detect those risks before they become failures. So the next time your product passes everything, take a step back and ask, did we test functionality or did we test reliability? Because those are not the same thing, and in this industry, that difference matters. So thanks so much for watching. If you enjoyed this video, don't forget to give it a thumbs up and let me know your thoughts or questions in the comments below. You can also email questions or comments to askdradam@KYZEN.com. If you're new here, make sure to hit that subscribe button and turn on the notification bell so you don't miss any new episodes. And as always, stay clean.